Okay, great. Okay, so shall I just start?
Yes, the size
Yes,
book.
sir. Yeah, perfect, sir. Yes.
All right, great. So, right, this is better. Right, so I'll just start speaking. So, this is about problem statement number two, which falls under the category of computer vision and machine learning both. Now, to just explain a little bit in more detail than what the problem statement says, this one is a computer vision based attendance system that I would like to put in my startup office. uh, Not something very complicated. I want a face recognition model. So there should be two parts to this. One part should be the registration of faces, right? So if there are four people in my office, I should be able to have a module where I can take a few photographs of their faces, feed it into a computer, and save it for reference. And the second part is the actual detection. So I want to put, I'll take this camera as an example. So I'll put this kind of a camera on my main door, and as and when people walk into the door, I want them not to have to stop and stare at the camera until the light turns. I want the system fast enough that as they are walking in front of it, the face should be detected, and the database should get the name that this is the person who has come. Correct? Now, two things of note here. I'm perfectly fine if you are not able to put it all the way up to a database. Even if you can detect the face and put it in an Excel sheet or put it in a notepad somewhere, I'm fine. Rest of the integration we can do at COPPERCLOUD. All right. But the important thing is the camera module should have a small processing unit, which is fast enough that somebody doesn't have to just stand in front. They should keep walking and the detection should happen. Right. The second bit is a bonus point is if it's easy to set up a new face. For example, there's some algorithms available using HAR cascades where you have to take 40 photos of somebody's face or 60 photos. It's fine, that will also work, but it will be better if you can just take five photographs or a single photograph using YOLO or something, and it becomes far easier to set up the system. So that's a bonus point. But even if it works with 40 faces, I can use the system. It's a one-time setup activity. Okay. So to summarize, two modules. Main part is the module that I'm walking into my office in front of the camera, and the camera detects my face and makes an entry somewhere, anywhere that Abhijit has entered. And this is the all computer vision systems gives you a probability. This is a 98% probability that this is Abhijit. And second is Abhijit has to be registered into the system. So the easiest way you can do, make an entry into the system, and then detection can start. This is problem statement number two from COPPERCLOUD. Problem statement number three again falls under computer vision category, not necessarily machine learning. There are multiple ways to solve this, and I'm not keen on imposing any one particular way. The participants are entirely free to choose an implementation they like. Okay, this problem statement is about a computer vision program that detects human presence, right? So it's a object detection, that human detection, but that's not all. I want to know how far away the human is standing from the camera. All right. Now these systems are not unique, but the unique part here, the little tricky bit here, is usually such systems require two cameras for binocular vision. I want to achieve this using a single camera, right? Now, what I want the contestants to do is, assume an average person height. Because if you're using only one camera, you cannot detect absolute. You have to take something as a reference. So take average height, 5 feet 5 inches or something, right? And thereby using various formula available in computer vision, I want us to look at the scene in front of the camera, detect where there's a person, and on the screen I want a pop-up or a text saying this person is standing 10 feet away, this person is standing 15 feet away, etc. Now, since you are making an assumption on an average person height, there will be some tolerance. So it doesn't have to be like 110% accurate. I'm fine with 10% here and there, plus and minus, because we are assuming an average height, which is fine. The camera can tell me the person standing 12 feet away when actually the distance may be 11 feet, but of course it should not be 5 feet. So some reasonable tolerance is expected. All right. So this is in summary again. I want a computer vision program which can use a camera, a single camera system, not two cameras. A single camera system that will scan the scene in front of the camera, mark out where people, human forms are standing, and assess to a reasonable accuracy how far away in terms of feet or meters or centimeters the person is standing, right? Feel free to assume an average height of a person because it's a single camera system, right? Um, Problem statement number 4 from COPPERCLOUD is very interesting for IoT enthusiasts. This falls under IoT and embedded systems. All right. Once again, this could be done through computer vision, so feel perfectly fine. It's to do it your way. So IoT or computer vision, both are fine. All right. Now this is a smart room scanner, right? So let us say you have some kind of sensors. I'll not impose a particular sensor. Use an ultrasound, use an IR, use a camera, whatever works for you. It needs to scan something. You have seen these radar stations where there's a radar scanner which keeps moving like this, right, and detects what's in front of it. So I want that kind of a sensor arrangement which is scanning a room at a periodic rate, and it needs to detect where are the humans standing in real time on an XYZ plane. All right, and the output I want on a computer screen somewhere. HTML will probably be the best. This is the kind of output. You can make it nicer, you can make it less nicer, doesn't matter. I want it like a radar plot. So wherever people have been detected in one sweep of the radio arm, I want the dots to be there. One problem you will come across is that you may not know that is this a person, is this a box, is it a pillar. Don't worry about that. We can add that intelligence later. Right now, assume that any person above a 3 feet table height, any obstacle detected above a 3 feet table height is a person, because there will be chairs in the room, there will be tables in the room. I don't want your system to count them as people. Anything standing above 3 feet height and obstacle that the sensor detects should be taken as a person, and the output I want in the form of this kind of a radar plot. All right. So again, a very quick summary. I want some kind of an IoT or computer vision system. Technology is entirely up to you. If you're using IoT, you will not need to use computer vision. So they are two mutually exclusive systems. The main function is some kind of a sensor which is rotating on an axis and scanning the room around itself. Anytime it comes across an obstacle, I want to treat it as a person standing there, provided the height of the sensor is about 3 feet, because I don't want tables, chairs, televisions counted as people. Don't worry about detecting people. Anything more than 3 feet height, take it as a person, right? And that's what this system is about. All right, guys. Anything more?
Yes, sir. Sir, was it all you are expecting from the participant?
Yes.
All right.
So will this work? I hope I have not made things worse.
No, sir. It's perfect, sir. That's all clear.
All right, great, good. So what else?
If nothing, sir, by this, the things will be more clear to all participants.
Of course. And from my side, right, if somebody wants to get in touch with me, I'm perfectly fine, because I want to use these systems that people will make.
Yes, sure.
I'm perfectly fine to entertain queries from people.
Okay, sir. Yeah, we will post this video on the YouTube. After that, we will ask participants to comment down below or reach us through email, or we can हम आपको contact करा सके.
When you reach out now, put an email ID. Don't put out the WhatsApp number.
No, sir. Yeah.
Yes, sir. Don't worry about that. We will either put the email, and we have dedicated Discord server to raise the queries. We will do that accordingly.
Fantastic. Great. Anything else I can do for you, gents?
No, sir. I guess we can conclude today's meeting.
Great. Thanks very much. Really appreciate you. Apologies if I missed one or two notifications you might have sent me about the video. But great. I like this approach. That just get it recorded and it gets done. Thanks very much for that.
Thank you, sir.
Thank you so much, sir.
Thank you for your time.
All right. Thanks very much. Bye, guys.
Bye, sir.